Hi everyone, welcome back. And in today's class, we'll talk about and learn about how to convert decimal number systems into binary and binary number systems into decimal. So before moving to the topic, as we can recap, as we are discussing about the number system in computer, okay. So we are just discussing about the number system, right? This was our topic, right? And in the previous class, we discussed that there are four major type of number system, right? So first one was, let's say, decimal number system. Let's talk about second, binary number system. Okay, let's take third one is octal number system, and the fourth one is, let's say, hexadecimal number system, right? Okay. So now, if we talk about this, we come to know about that the total digits used in the decimal number systems are 10. Okay. So base will be 10. So we can denote that with total number of digits used in the number system as a base. Binary, we use only 0 and 1. So we'll call the base is 2. As the name suggests, octal. So here we are using numbers from 0 to 7, total 8. So the base will be 8. The hexadecimal number system having, two words. So hexa is 6 and decimal is 10. It means there are total 16, digits and let's say, yeah. So used for this hexadecimal number system, right? So what will happen today, let's say, if we talk about that, how we can convert these decimal numbers into binary number system. So this is very simple way to do. So that is called as long division. Let's take one example. Okay. What that example is, let's take 36 is a number. Okay. So we'll write 36 number as and we'll denote that base with 10. And the question is, let's say 36 means in binary, how will show this? So what this question says, this question is indicating that we have been given a decimal number and we have to convert that to binary number system, right? So in this scenario, what we'll do, write the 36, okay, as it is, and then you can just draw vertical lines like this. So we use this for division method also, right? So you know that when we, used to take out LCM, HCF, there also we are using this. So this is like the same. The only difference is that we'll take, what we'll take? 2 as a number to divide, because in binary, we have the base, there are two digits, right? Now, 0 and 1. So let's take the base as a 2 and let's divide this. So if we'll say 2 times 18, we'll get, 36 as answer, but remainder will be 0, right? Now, next time what we'll do, let's go for the another number. Let's say 2 times 9. Now, this time what will happen again? 2 times 9 is 18. So 18 minus 8, 18 minus 18, again we'll get the answer as a 0, right? After that, again we'll do that one thing. Let's stick to the number 2 only. Let's take 2. Now 2 times 4 is 8, So 2 times 4 is 8. So 9 minus 8 will be always answer 1, right? After that, let's say one more number, 2 times 2. So what answer we got? 2 times 2 is 4. Again, we got the answer as a remainder as a 0. Now, here is a 2. Okay, let's draw one more line so that we can finish it properly. Let's take the yellow color and let's go for now. Okay, if needed, we'll draw again. Okay, fine. That's it. Now let's go for another number. Let's say 2 is here. So 2 times 1 is 2. So 2 minus 2 is 0, right? Now, next number, the last number, let's do that. 1 should be divided, right? So that now let's say the last step we just reached now. And let's take 2 times 0. We'll get the answer as a 0. So let's say 1 minus 0 will get the answer remainder as 1. So now, whatever the number we got, look at these numbers. We'll start with the bottom, right? This very simple technique we should remember. And now we'll write the numbers from lower to the higher, from lowest to highest position like this. Okay, now let's say we'll write the number. What number we got? We got, let's say, 1 0 0 1 0 0. Okay, so this is binary number we got for 36. So we'll write 1 0 0 1 0 0. Is it clear? Now let's say the same number I wish to prove that now. Let's say now this time I have a binary number and I have to show that what will be the answer for that binary number into decimal. So vice versa, what we did here when we were doing decimal, we decimal to binary, we were using, division method, right? Now, when we'll go for binary to decimal again, let's say binary to decimal. So what we'll do? We'll do the exact opposite of the division. So that is multiplication, right? So let's say now this time we are going to do binary to decimal conversion. Okay, let's do this. Let's take the same example. Let's say we have the number 1 0 0 1 0 0. The base is 2 here as it is a binary number, but we are looking for what will be the value of this number in the decimal number system. So what we'll do now, let's say we'll write these numbers, same numbers we'll write as it is. Let's say 1 0 0 1 0 0. Now what is to be remembered, the very important thing is that in binary number system, let's say the place value begins from the rightmost side. So let's say this is the first place, so we'll write here 1, then it will get increased by, let's say, double twice. Now let's say next place value will be 4, next place value will be 8, next place value will be 16, and after that we'll get 32. Fine. So now these are the place values at the top we have just written, right? So let's put that place values in a box so that we should not get confused. Okay, so this pink box we just considered for the place value of these digits. Okay, place values, okay, in binary. Fine. So now how I will represent this, okay, in the form of exponent. Okay, so let's say the number is here 0. Let's say this is 0. So 0 times 2, right? So if I want the answer as a 1, let's see if I'm writing here base 2. So I will give the exponent as 0. Any number, in a previous class also we discussed about that, any number having power or exponent as a 0, always return the value as a 1. Okay. Now same thing we'll do with this. Let's say now this time we have the same number here, 0 times 2, but exponent will get increased. Okay. So 1. After that, next number is 1 here again. So we can do that 1 times, 2 times. The exponent will be now 2, right? Now, next number is 0 again. So 0 times, 2 times, exponent is 3. Same, 0 times, 2 times, exponent will be 4. And here 1 times 2, the exponent will be 5. Can you find any relationship between this exponent and the place values which are written at the top? Okay, let's say if you wish to cross check, let's talk about the 32. You can see the 32 here. Let's see 32. So if I'll write 2 times 2 times 2 times 2 times 2, 5 times. So let's say 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. Now you got the logic. If the place value is 32, the exponent is 5, right? Let's write here now the products of the given numbers. 0, because the 0 multiplied by 2, always 0. Here also we'll get 0. Here we'll get 1 times 2 times 2, right? Here we'll get again 0. Here also we'll get 0. But here we'll get 1 times, right? 2. How many times 2? 5 times. So the answer is, we'll get the answer for this is 32. Let's say this is 0. This one is also 0. Here you can just pay attention. Here you will get the 4. Here is a 0. Again, here is a 0. So if we'll add these all numbers, we'll get 32 plus 4. The answer is 36. Okay. Now, very simple technique to remember that. Whenever you will have a 0 in binary digit, okay, so there is no need to actually find out the values of these zeros. Wherever you will have the 0, nothing to calculate, because you will always get the answer as a 0. So we can actually save a lot of time by removing all these, zeros, but will not change the place values. The numbers will be there on their own places, but whatever the red circles you see on a screen, those values, nothing to calculate about that, because finally we'll get the 0 as answer, right? So it means what? Wherever we see 1, on the 1, we get the answer as a 32. Okay. And then one more number is here. You can see, just check this. Here we got the answer as a 4. And here we got the answer as a 32. So only if we can add these two numbers, we'll get the answer as 36. Now, by doing this, we can prove that decimal number can be converted to binary and binary can be converted to decimal. Practice few more examples for better clarity. You will definitely come to know about that, how to get this. This is very easy technique. Next time we'll talk about, let's say, addition and subtraction of the decimal numbers and binary numbers. Fine. That's it.